So hello everyone. So I'm back again with another project that I've been working on using machine learning. So basically the project that I've been working on is now on the sign language detection using YOLOv11, which is the latest model available on the Ultralytics. So the project that I worked on is to aim communication gap using this by gesture by using some recognizing the common sign languages in real time. So basically, the my project that I worked on will detect some of the common sign languages. Then, based on the sign languages, it's gonna provide me like if it's hello, then it's gonna say hello. If it's bye, it's gonna say bye. So all you have to do is train those data sets. So you have to feed your data sets like what you want your model to respond to. So these are the American Sign Languages. You can use the American Sign Languages for your data sets. Like there's alphabets available. There's lots of American Sign Languages. If you want, you can use American Sign Languages. All you have to do is go to this RoboFlow, then search for data sets that has American Sign Language. You can see that there's rock, paper, scissors data sets available. Now we're gonna search for sign language. It's American Sign Language. So you can see there's lots of data sets available. Here you can see 50 images available, data sets available on Russian, I think it's Russian sign language. And also there's lots of data sets available. You can see 277 images. But make sure that if you use the larger data sets, and it's gonna require larger GPU storage, CPUs. So make sure to use data sets carefully. I've already exhausted like two of my Google Colab account due to this RAM issue. Like I have to run through the Tesla 4 model, which is not Google Colab Pro. So I would suggest if you have Google Colab Pro, it's really great for you train your model. So this is the code that I worked on this past couple of days. Following a video on the YouTube, you can search on YouTube. You'll find lots of videos on this available, but mostly the code that they provided is face you will face error because the datasets aren't available that much. So you can see I've already used the Tesla 4 model. I don't want to run this again because I've already exhausted my GPU as I've told you guys. So I don't want to get out of RAM for this again. So yeah. Then I've also ran this pipe install Ultralytics library. So basically, it's going to install the Ultralytics library, which has the yellow version, which will provide us the yellow V11. Then we will import all the library, import yellow, import image to display our images on our screen. So the image they provide gonna be show up here. Then so this is the Google Drive that I provided. This actually contains the datasets that I provided them. I've only provided the 16 images, so it won't take that much training. So I would suggest you to train with your own datasets because the larger datasets you are gonna provide, the more accuracy the model will perform. So if you want the model to be accurate, you have to provide with more datasets. I've only provided small amount of datasets because I would just want to test it out. Just randomly testing out. So it's up to you how much dataset you want to provide. So it's gonna download the datasets in the Google Colab, and the Google Colab gonna show up here. You can see the files. There's files, and it's gonna show up here. The files that you're gonna train gonna show up. All the files will be show up here. Then you're gonna unzip the sign data file. The dataset contains the sign data file. So it's gonna unzip those files. Then lots of datasets will be unzipped. Then we're gonna train our model. So you can see our yellow model is training. So this is the data that we're gonna feed into our yellow V11, and this is the yellow V11 model. We're gonna train it on the 50 epochs. So the more epochs you're gonna train, the more better you're gonna perform. So, but remember we have GPU issues. So make sure to be more careful. But if you have Color Pro, You can use like, let's go to notebook settings. You can see where you use the T4 GPU model, but if you have Colab Pro, you're gonna use A100 GPU. This is the best available on the Google Colab Pro. So I would suggest if you have Google Colab Pro, it's really great. Also, I have an NVIDIA GPU as well on my PC, but due to storage issue, I didn't train it here on my PC. So yeah, I think I've gone a little down. Let's check. So you can see our model is trained. Let's go up down below. So you can see how the model train has gone. So we're gonna so the our model has detected hello, then it detects this. It's the confusion metric of my model, like how it's performing. And it's performing thank you on the 0.2 to 0.0 confusion metric range, then it's performing on the I love you on the it's perform mostly detects hello as the highest confusion metric. So yeah. And let's go down below. You can see the graph. So basically that it's saying the how many data sets of my available. So basically the hello is available on the 6 to 5, which indicate the 5 instances, then I love you on the 4 instances, then no on the 6 instances, thank you on the 6 instances, no 5 instances, and yes on the highest like 10 instances. So this is the image that they're gonna show us like how's the training performing, how my training perform in the data sets. Then let's go down below. You can see that my training graphs, like how the training is detecting our model, the results of my training metrics, precision, recall, all of them is available. You can see available. All you have to do is run this code and just go down. Then you can see these are the data set that I provided. These are the data set that I created using the label box. So you can, if you want, you can use the tutorial file that I provided on my GitHub. I will put it on the description box. So if you want, you can check the description, then create your own data sets using the label box that I'll provide on the tutorial.ib file. So make sure to check that out and create your own models. All you have to do is open your webcam, then train these data sets. And also you have to annotate some data sets using the square box. Like you can see that I've annotated my data sets. So make sure to annotate your data set correctly. So this 0 for hello, then 1 for I love you, 4 for the yes, and 3 for the thank you. So it's putting all the numbers on my detection. So it's performing really well. I have to train it a lot to perform it well. Like you can see that I've also trained it using the 100 epochs, which has already exhausted my GPU on my T4 Tesla GPU. So yeah, it has taken a lot of GPU. Then you can see the metrics, model dot value. You can check out the metrics available box 0.556. You can check out the performance metric. Then let's go down. You can see that I've also trained it again because I wasn't getting the result that I've expected. So yeah, I have to train it again. Then after several training, that I got the result that I wanted. So it detected hello on the labels folder, and it detects thank you correctly. Then it takes the I love you as this. So this is a random detection. So these are not the actual American Sign Language. These are my this just I randomly selected this. So if you want, you can create your own dataset or use the created one on RoboFlow, then train this for fun or for your research purposes. So yeah. So this is the yellow task. So yellow is gonna perform the task to detect, then it's gonna detect the model, then put those on the predict folder on the files section. You will find it here. So it's gonna perform the prediction, then put those images on the predict folder. Then let's go down. Let's see how the model had detected. You can see that 0.81% had detected it's no. So the model is performing really well. So yeah, now let's go down. 0.81 as the no, that's great. I have to train it a lot, guys, to make it accurate. Also exhausted lots of GPU from my account. So yeah, you can say I've used the 0.25 confidence score. You can reduce your score if you want, like 0.110 to test to make your model more accurate. And also it's gonna predict and put those on the predict run, detect and predict folder. You can see that you have detected I love you. 0.63% detected I love you. That's great. Then let's go down. I've also trained it using video datasets. So let's see how it detects it on video. So you can see first it detected no video, no detection, no detection. Then I guess after several times it detected. So I think it's on the previous video that I fed on. So yeah, that wasn't accurate, but I obtained it again to make it more accurate. So if you want, let's check the video out. So you can see that it detecting hello. Look, let's pause it and look at the detection that is performed. It's not accurate as I've not trained it with much dataset. I've only trained with 16 images. So this are really less datasets. So the more dataset you're going to provide, the more accurate it's going to perform. That's why my dataset doesn't perform that well. So I've trained it again and again. So make sure to feed more datasets, but also GPU is also the issue when training. So make sure to have Colab Pro or another Google account if you want to train it. So that's the project, uh, all about my project. So I will provide this link to my code and the tutorial link on the description, YouTube this video's description. Then check that out and train your own datasets. All of the codes are provided here. So yeah, best of luck with your training and see you all on my next video. Thank you so much.